Here's a solution to a simplified version of one of the homework problems. Here we're asked how many 5-digit numbers have all their digits in increasing order. And the key observation is that if you give me any set of numbers, there's only one way to put them in increasing order. So if I want to construct 5-digit numbers that have their digits in increasing order, I could do it in 2 steps. I could just pick any 5 digits, so any 5 numbers from 1 to 9, and then there's only one way to put them in increasing order. Notice that when I make that selection, they have to be 5-digit different numbers, or I wouldn't be able to put them in strictly increasing order. So the way we can envision that correspondence is here. Over here I have the subsets of all 9 digits I could use of size 5. Notice I'm not allowing the digit 0 just because I'm going to put those digits in increasing order, and if 0 was included in one of these, then when these go in increasing order, I'll have a leading digit of 0, and then technically that wouldn't be a 5-digit number. So I'm not allowing 0 to be one of my choices, but I can take any subset of the numbers 1 to 9 and then just put those 5 numbers into increasing order, and over here I'll have the list of all 5-digit numbers with their digits in increasing order. So we're in the same situation we were with some other problems that we've had, where we have the thing we're trying to count on one side of this correspondence, and we have something that we already know how to count on the other side of this correspondence. And because these connections are one for one, we will have the same number of things over here as we have over here. So the number of subsets of size 5 from 1 to 9 is just 9 choose 5. So that would be the answer to the first problem. The second question asks how many of these have 7 as its rightmost digit. And we have one example here. This one has 7 as its rightmost digit. The other ones don't. The thing that makes it have a 7 as its rightmost digit is that 7 is the biggest number in the set. And so this would be the same question as asking ourselves, as I've written on the right, how many 5-element subsets of the digits 1 to 9 have a maximum value of 7. So this set is one of the ones I would want to count. I'm picking 5 numbers from 1 to 9, and 7 is the largest number that I picked. This one would not be, because 7 is not the largest number in this set. 7 is not the largest number in this set, and so you can see that when we sort it out in increasing order, we don't have a 7 over on the right-hand side for these numbers. So as long as 7 is the largest element of this set, then when we make this correspondence, 7 will be the biggest biggest digit, and therefore the digit on the right. So how many 5-element subsets have a maximum number of 7? Well, we can construct these. I can construct these in 2 steps. I'm going to definitely use the number 7. So I'm going to choose 7 from the set 7. I'm going to choose that number to use. So I definitely want to put that in there. And then my second step is going to be choose any other 4 numbers. But if 7 is supposed to be the maximum number in this set, then the other 4 numbers have to come from 1 through 6. Okay, so I'm not choosing 7 numbers from 7. I'm just literally choosing the number 7. So as I'm making up this 5-element set, I'm going to take the number 7, and I'm going to pick any other 4 numbers from 1 to 6. And I throw those together, and I will have a set whose maximum value is 7, and that set will have 5 elements. So the total number of ways I can do that, obviously I only have one choice for step 1. There's no choice here, so there's one way to do that step, and the number of ways to do step 2 is just 6 choose 4. And so 6 choose 4 would be the answer to number 2.